we're asked to calculate the slope of the tangent line to the graph of the function x squared plus 1 at some initial point x naught equaling to -1. So let me go ahead and graph this guy out for us. Okay, so we're asked, to find tangent lines for this function. So let's go ahead and graph this guy out. Squared function raised up 1 unit. So here it is. I'm going to plot some points here. Okay, so at 0, at 0 this is at a height value of 1. At x equals 1, it's at a height value of 2. At x equals 2, it's at a height value of 5. And when x is 3, it's at a height value of 10. So it's way up there, right? So I'm just going to graph this side of the curve. That's really all I need. I could graph the other side if we needed, but we don't. Actually, sorry, we do. Because we've got to go over here to -1. So at -1, we're at a height of 2. And at -2, we're also at a height of 5. So my apologies. We still need that. So let's... Now we want to find the slope of the tangent line at this point right here. So I'm just going to sketch in the tangent line. Just going to eyeball it in. There it is. And we need to find the slope of this guy. Now the slope of that guy is sometimes called the derivative, and that's partially true. The derivative is an actual equation. So the derivative is an entire equation that gives us the slope of the tangent line anywhere along the curve. So we're looking at a specific point and we're looking for the slope here. So I'm not going to necessarily call it the derivative, just call it the slope of the tangent line. Now how am I going to get that? Well, what I'm going to do is I'm going to grab another point that is just a little bit away from this -1. So we've got -1 here. Okay. Now to get an estimate for the slope of this line, okay, what I could do is I could grab another point that's relatively close to it. Okay. So I'm not going to say exactly how close to it. I'm just going to say that it's relatively close. So let's grab another point right, it doesn't really matter where I grab it, right here. Okay. Now this right here was our initial point, x naught. This point right here, we're going to let it go over just a little bit. And that little bit we're going to call delta x. And so we're going to take the delta x value and we're going to add it to -1. So this guy right here is -1 plus a little bit. Now its height value, we need to know that as well. Okay, so the height value here is the function evaluated at -1 plus a little bit. And this point right here, if you remember, this is just the function evaluated at -1. And the function evaluated at -1 was 2. So here's what we've got. The red point has the following for its ordered pair, its coordinates. It's -1 and then f at -1, or another way to write that is -1, 2. That's clearly the point, the red point here, that we're trying to find the tangent line at. The other point is an arbitrary point that's just a little bit away from -1. It's -1 plus a little bit. And so the green point is at -1 plus this little bit, okay, this little bit right here, and then f at -1 plus a little bit. That's its height value, right? So now we've got these 2 points, okay? One is here, the other one is here, and we need to calculate the slope. So the slope of the line is the change in the y values over the change in the x. So the change in the y values, that's going to be 2, well, I'm going to use this one first. It's going to be f at negative 1 plus delta x minus f at negative 1, which is 2. The bottom is going to be negative 1 plus delta x minus a negative 1. So let me point out where I get these values from. Okay, we'll do it in purple. This guy right here, let me erase a little bit here to get this clear. This guy right here is y2. This guy right here is y1, which is the same as this guy right here. And we're gonna plug this 2 in right here in just a minute. This guy right here is x2, and this guy right here is x1. And what we've just calculated is y2 minus y1 over x2 minus x1. It's the same idea. Okay. So, okay, what are we gonna do? Well, we gotta do a little bit of algebra up top here. Okay. So I'm gonna rewrite it down here. So for a little bit more space, we have f at negative 1 plus delta x minus f at negative 1, and that whole thing is over negative 1 plus delta x minus negative 1. So we do some simplifying. What is f, excuse me, what is f at negative 1 plus delta x? Well, f is a function that is defined as x squared plus 1. So it's equal to something squared plus 1. So f at negative 1 plus delta x is negative 1 plus delta x squared plus 1. Now we'll go ahead and we'll do our math out here. So it's negative 1 times negative 1, which is positive 1. So we're going to get 1 minus 2 delta x plus delta x squared, and then plus that 1 still at the end. If you FOIL this, you get this. If you don't see that, you need to go back through and actually multiply this out. So that's this first guy right here. So that's going to be equal to 1 minus 2 delta x plus delta x squared plus 1. Now we have to subtract f. So we're going to subtract f at negative 1. Well, we know f at negative 1 has a height value of 2. So we're going to have to subtract 2. And then we're going to divide it by negative 1 plus delta x minus a negative, which is plus 1. Now usually at this point right here, things start to cancel out real nice. So let's take a look at those. Well, 1 plus 1 minus 2, that cancels. And negative 1 and positive 1, those cancel. So what I'm left with is negative 2 delta x plus delta x squared over delta x. And so this, if we factor out a delta x, we get negative 2 plus delta x over delta x. And since, and this is really important, since delta x is not 0, that's the idea. Okay, delta x can't be 0 because otherwise these 2 points are the same. That implies that this is equivalent to canceling the delta x's out. And so we're left with negative 2 plus delta x. Now the question is, what happens is delta x becomes really small. And that's the idea of the tangent line. So for the tangent line, what happens to what happens to, I'll word it out like this. Okay, what happens to negative 2 plus delta x as delta x gets really small or goes to 0? And what happens is negative 2 plus delta x goes to just negative 2. And how we write that is we say the limits as delta x goes to 0 of this is equal to just negative 2. And so what that says is that when this delta x value right here becomes super small, the slope of this line right here is actually equal to negative 2.